Alright, so we're going to go over the solution to the seventh problem in the grind 75. This one is a valid anagram. And in my actual attempt, I was able to get through this, and the logic I used was correct, but there might be a way to optimize it even further. Just to go over what the problem is again, basically we have to see if one string is an anagram of another, and what that means is that every character and the amount of times that it's found in one string is the exact same in the other. So for example, if there are 3 A's in this string, there must also be 3 A's in this string. And this case is true. So what I did was, first off, check to see if the length was the same. And that was a good check because it can weed out at the very beginning whether or not the two strings could be anagrams. But the next thing that I did was create a hash map and then add each character and their counts for one string to that, and then decrement by iterating over the second string. And that works. It's just, it might not be as memory efficient because we have to constantly resize the hash map. Even though it's pretty much just like a set, so it shouldn't add too much. One thing that's seems to be a common trope across these problems is to create an int array or some type of array to represent the characters, because characters in ASCII, which are lowercase, uppercase, and numbers, they have a corresponding numeric value. So just so we can look at what that looks like. I will comment this out and we will move this to the bottom. And what we are going to do is create an integer array, and maybe not in caps lock, please, an integer array. And this will be called, since we're only dealing with lowercase letters, it's going to be of size 26. So close a new int array, and this is going to be of size 26. And what we're going to do is, as we saw in, so the way that I did it here was added each letter and its counts, and then decremented as we iterated through the second string. And what I did at the end is check to make sure if the hash map was empty, because every time the count hit 0 once we were iterating through the second string, then we would just remove the letter. In this, we are going to iterate through this twice, and let's see. Yeah, so we're going to iterate through this itself just once, actually, sorry. So what we are going to do is for int I, while I is less than, could be either, because we know that they are the same length if it's gotten past that. For int I, what we're going to do is we're going to change the count at this array. This array is basically going to represent the number of times we see a particular letter in this original string. And anytime we see a letter in this string, we're going to want to decrement the count. So what we're going to do is say we're going to get the char at I, and we're going to subtract by a, and we're going to do the same thing here p.char I subtract by a. And we are actually going to want to, let's see, plus plus and minus minus. Okay, I believe that's right. So basically what that does is every time that we see a character in the original array, we're going to add it. Every time we see a character in the second array, or second string, sorry, we're going to want to decrement it. And in this case, we're going to then iterate through the letters array again. So maybe int j is equal to 0, while j is less than letters dot length, and going to, if you think about what needs to happen, there needs to be the same number of each letter found across both strings. So if we add 3 A's, then we're going to also want to subtract 3 A's. So that means every count in the letters array should be 0. So we're going to say if letters at index j does not equal 0, then we're going to want to return false. And if we make it through that, then we know we can return true. Okay, and that should work. Let's just submit really quick. And yeah, that works. So that's just another approach. I believe the memory usage might be a little bit less, but I know that for other problems that involve strings, having a knowledge of this thing right here, where we can get technically the ASCII value of a character by subtracting it from the very first ASCII value, that's good because then it allows us to know its position in an int array. If we were to use the full set of ASCII values, which is lowercase a through z, uppercase a through z, and then numbers, and then some other special characters, it would actually be a new int of size 128. But again, we would still subtract from lowercase a because that was the first character. So the reason why I showed this implementation is for me to remember this trick of using a fixed length array, subtracting a character by lowercase a to then get its index in this fixed length array, which represents where each index is the equivalent ASCII value of a character. So yeah, not too bad of a problem. Definitely kind of it was an interesting problem, but I will end the video there.